These first four look like exponent problems. First thing you want to do is deal with the powers. So I'm going to take this 3 and remember, if you take x to the 7th, y to the negative 2nd cubed, you get 3 groups of that. Well, 3 groups of 7 and 3 groups of negative 2 give you 21 and negative 6. Remember, if you have a power, to a power, you're going to multiply. So when you get down to here, then you're just saying, okay, you have x to the 5th, y to the 21st. How many total do you have? You know, the 26th. You are going to take both of those negative powers, move them in the denominator. So once you put both of the 6's in the denominator, you have 12 in the denominator. So you get your answer. Second one, go ahead and make this negative 3, negative 12, negative 15, but then they all flip because of the negative exponent. And there's really nothing else to do other than 4 cubed is just 64. This one, go ahead, the negative sign's going to flip everything, and then squaring it gives you 5 squared, which is 25, x to the 8th, y to the 4th, and again, they flip because of the negative exponent. And then y to the 9th is going to go to the denominator. X to the 5th, x to the 7th is really just an x squared. And then you just do a counting of everything. So, you know, x squared, x to the 8th, x to the 10th. And then you're going to reduce. So 25 over 10 over 25 is just 2/5 and stuff like this. Y to the 4th over y to the 9th is just y to the 5th when, you know, you play the cancel game. Same thing on number 4. 8 over 12 is 2/3. That's x to the 5th, x to the 7th is 12 of them. 12 over 3 of them is just 9 of them. Move that y to the 5th to the denominator, and then you have 9 of them, and then you get the answer. Okay. 5, synthetic substitution. Remember, you're putting the number you want to substitute in on the top left. You're writing the coefficients, and if you end up skipping anything, it looks like we don't. So cube term, square term, linear term, constant. If there was a skipped one, you'd have to put a 0. Go ahead and you bring down and then multiply. Add, multiply, add, multiply, add. And so this negative 375 is the answer that you would get if you plugged in negative 4 into this function, which means it is the same thing as saying f of negative 4 equals negative 375. Okay, you got a negative cubic function. Remember, the big dog here is going to determine what the shape looks like. And so off to the side here, you got generally what a negative cubic looks like. And so you know if you let x go to negative infinity, so way to the left, it's going to go up. And then as x goes to positive infinity, meaning as you scroll to the right on the graph, you go down. So you go to negative infinity. Now a positive x to the 4th, that looks kind of like a W. And so both end behaviors are going to go up. So both of them are positive infinity. Standard form here, just rewriting it in the right order. So cubic, then square, then linear, then number. The leading coefficient is positive or negative is going to tell us, you know, to help us tell us the general shape of something. It is a cubic, it is a degree 3 or order. And then in this case, it's just 4 terms, so we just call it a polynomial. Over here, we have 3 terms. Leading coefficient is 5. It's the coefficient of the big dog. Because it's a quadratic, or because it's an x squared, we do have a special name for it. It's a quadratic. And then since it's 3 terms, it's a trinomial, where 2 terms is a binomial, 1 term is a monomial, and anything after 3, well, we just call polynomial, meaning many. Over here, standard form, negative 4. It's a cubic, it's degree 3, it's a binomial because it's 2 terms. It's degree 4, it's a quartic. The leading coefficient is 5, the constant is a 1. Over here the constant would be a 0, here the constant would be negative 7, here the constant would be negative 4. Remember, our constants are our y-intercepts. And again, since it's 4 terms, it's just a polynomial. Okay, is the function a polynomial? Sure. This square root of 10 is just a coefficient. That's just a number. It's an irrational number, but it's just a number, and you're allowed to have a number as a coefficient. The exponents themselves have to be whole numbers. So 0, 1, 2, 3, 4, 5 stuff. This one is a no way Jose, because the x is in the denominator, which would really be the same thing as x being a negative exponent. Okay, even or odd, origin symmetry for an odd, no symmetry here at all, so it's neither one. And this has y-axis symmetry, so it's an even function. Increasing and decreasing, right? It's going to be increasing from negative infinity to all the way to negative 4, and then it's going to be increasing from negative 1.333 all the way to infinity. So there's those two areas where the function is going up, and then there's this one region from negative 4 to negative 1.33 that the function is going down. This is a relative maximum here, or down here is a relative minimum. It's all the way at the bottom, and then end behavior on the right it goes up, and on the left it goes down, and that's what this is saying there. All right, and then lastly we just got some polynomial operations. It looks like this first one is adding and subtracting polynomials, distributing, distribute that negative sign, and then combine like terms. Over here, go ahead, if we have something squared, go ahead and write it out as it times itself, and then distribute and combine like terms. Cube, same thing. Take your time, do the first two terms to give you this, and then take that guy into the next. And we get the same thing when we combine, and it looks like we've color-coded it a little bit, where we distributed the 4x, and then distribute the 20x, and then distribute the 25. And the cubic terms go with other cubic terms. These two squares go together, and these two linear things go together, and then the constant. Okay? So this is definitely a good example of what the test will look like. We have some polynomial operations. We have maxes and mins and increasing and decreasing and end behavior, even and odd symmetry. What is a polynomial? Classifying polynomial, writing them in standard forms, talking about the lead coefficient and shape. And then at the beginning using direct and synthetic substitution. And then certainly at the beginning of the test, I don't know, 4, 5, 6, 7, 8 questions over properties of exponents.